Okay, so now that we've done electron configuration, we want to focus our attention on valence electrons. Now your valence electrons are going to be the electrons that are in the outermost shell. And it is these electrons that are involved in bonding. All right. So I want to focus on hydrogen first, right? So hydrogen sits right here. Hydrogen's configuration is 1s1. It only has one electron. That one electron is in the outermost shell, which that shell is 1. And so we have one valence electron for hydrogen. Okay, I want to talk about oxygen next. So oxygen sits right over here. Now, to get the configuration for oxygen, we went all the way through energy level number 1 to get us 1s2. Now remember in a previous slide I said once you've gone all the way through an energy level and you filled it up, that is a full energy level, right? And those full energy levels are not going to be involved in bonding at all. They're full. Once an energy level is full, it is stable. It does not want to give away electrons or mess with its electrons at all. So that's why it's not involved in bonding. Now, to complete the electron configuration for oxygen, we went through 2s2 and 4 spaces into the P. I did not completely fill that second energy level, right? For that second energy level to be full, I have to fill both the S and the P. So that means that 2 electrons from the S and 4 electrons from the P are my outermost electrons. Oops. Right, so these guys are going to be my outermost electrons. So it will be the 2 from the 2s and the 4 that give me 6 valence electrons for the oxygen. All right, chlorine is next. And now anytime we're really nice to you and we give you a noble gas configuration or a shorthand configuration, essentially what we're doing here is we are telling you that those electrons that are represented up to neon are full. So we are saying that those electrons are full and that my valence electrons are going to exist in that third energy level. I did not quite get that third energy level full. Here's my chlorine right here, right? So that energy level is not quite full. And I have 2 electrons from the S and 5 electrons from the P, giving me 7 valence electrons. All right. Now, here is your shortcut. So the A block elements. The A block elements are going to be these and these. Essentially all of your S and P block elements. Okay, those are going to be your A block elements. For those elements, the group number is equal to the number of valence electrons. So, and you just have to love that every so often something in chemistry is super straightforward. So for everything in group 1, you have 1 valence electron. For everything in group 2, you have 2 valence electrons. For everything, now we're going to jump over, right? We did not talk about the transition elements. Those don't follow the same set of rules. So for everything in group 3, we have 3 valence electrons. For group 4, we have 4 valence electrons. For group 5, we have 5 valence electrons. Group 6, 6 valence electrons. Group 7 is 7 valence electrons. And now for the last column, it's 8 valence electrons, it's 8A. Just keep in mind that helium is a little different, right? Helium really should go over here. All right, so the last thing we're going to talk about are Lewis dot symbols. These are a different way for us to represent the valence electrons for an element. The rules are that you do 1 dot per side before you go back and pair them up. And for these elements, you'll have a total of 8 dots. It turns out 8 is a magic number. And that is because we are going to be focusing on the s and p orbitals. And again, we're only going to be focusing on those A block elements. All right. Well, let's start with my favorite. We'll start with hydrogen first. Right? We talked in the previous slide about how hydrogen only has 1 valence electron. And if I had forgotten that, I could just take a look and see what group number hydrogen falls under. It's in group 1, and so therefore hydrogen has 1 valence electron. So hydrogen, 1 valence electron. To draw my Lewis symbol, I'm going to write out the formula or the symbol for the element, and then I am going to represent my electrons as dots. I have 1 dot, and so that's it. I'm going to go ahead and represent that 1 valence electron with 1 dot. Okay. Let's take a look at carbon. So carbon is over here, and I could go run through the configuration to figure out the number of valence electrons, but since I now know the shorthand or the cheat, I can see that carbon sits in 4A, and so I know that carbon is going to have 4 valence electrons. So when I do my symbol, my Lewis dot symbol for carbon, again I mentioned that I want to have 1 dot per side. So I want you to think about this almost like it's a box. Like I have a box around the outside of my symbol. And I'm going to go ahead and I'm going to add my dots, and I want to spread them out, right? So I want to do 1 dot per side, unless I don't have a choice and I have to go back and pair them up. But there are 4 sides, so I can represent that Lewis structure with 4 dots around the carbon. Okay, let's do sulfur next. So sulfur is right here, and sulfur sits in group 6. So sulfur has 6 valence electrons. And to do my Lewis symbol, again, I want you to picture that imaginary box around your element. And I'm going to go through and I'm going to put my dots around the sulfur, 1 at a time, right on one side of the box. And now once I've hit 4, since I have 6 electrons, I have to go back and put 2 more in. And that is how you draw a Lewis dot symbol.